These are the lecture notes for Chapter 1, and this is the second recording. So we're starting with Section 1.4, Characteristics of Life. So these are characteristics of all living things, but of course they're characteristics that all humans share. So living things are organized. They have organization, and we learned about that. Sorry, I don't get a lot of text, and I didn't turn my volume down on my phone. But anyway, organization. So we're organized from atoms grouped into molecules grouped into organelles grouped into cells grouped and form tissues form organs form organ systems, and then all 11 organ systems make up the human organism. So that's what is meant by organization. Metabolism is referring to chemical reactions. So it's the ability to use energy to perform vital functions. And it includes all the chemical reactions that occur inside of the human body and inside of human body cells. So it would include breakdown reactions and building reactions, like when small atoms or molecules are used to build larger ones. So when the body produces enzymes and hormones and that kind of thing. Okay, responsiveness is the ability to sense changes in the interior and exterior environment. So changes inside your body and outside, and then adjust to those changes. So cell-to-cell communication is necessary. So cells have to have some way of communicating with the cells that are directly beside them, which we will talk about more later. But responsiveness is a really large component of the nervous system, for one. I mean, that's just one example. And then growth is either an increase in size or increase in the number of cells. It's how we get larger. So we get larger, taller and wider, either by our cells getting larger, and also, I shouldn't have said either. There's two ways we get larger. Our cells divide and we increase the number of cells that we have, and the individual cells can get larger. I don't know why that was so hard for me to say. I'm probably the only one that goes through that. But development refers to the changes, like stages of life that organisms go through, that humans go through, like infant to toddler to adolescent, elderly. And then differentiation is what happens when early in development, when the cells that were forming the embryo start to specialize and become skin cells or blood cells or nerve cells. They differentiate or specialize. And then morphogenesis is the change in shape of tissues, organs, or the entire organism. Morph refers to shape or form. Reproduction is forming new cells. So when our cells divide and form new cells, like when our skin cells are shed and we form new cells to replace the cells that we lost. And then also reproduction refers, of course, to making a baby. So how organisms pass their genes on to their offspring through the genes contained in the egg and the sperm. Now we're going to go into homeostasis. And I would say at this point, from this point to the end, is the most important part of Chapter 1 for you to learn. So you definitely need to understand homeostasis. It's the maintenance of relatively constant internal environment within the body. The conditions that are being maintained are called variables. So in this example, the variable is body temperature. And I'm sure you know body temperature doesn't stay at one set value, but it fluctuates. But it stays very, very close to the average for humans is 98.6 degrees Fahrenheit. So the human body temperature stays very close to that, 98.6. And when it rises too high, above 98.8, or too low, below 98.4, that is going to lead to, your body is going to do something to try and return the body temperature to its healthy set point or ideal normal value. So the set point is like 98.6 degrees Fahrenheit in this example. The normal range is from 98.8 to 98.4. So homeostasis is regulated or controlled by feedback loops, and you definitely need to know what negative feedback and positive feedback are. You need to understand the definition of each, and you need to understand examples. So any feedback loop will have receptors which monitor the variable. So like it would tell you that a receptor in your skin can tell you that your body temperature is rising too high. Control center is going to be typically the brain. It's either the brain or the spinal cord almost all the time. And it's going to receive the information from the receptor. So like the hypothalamus in the brain will receive the information from your temperature receptors in your skin. And there are also temperature receptors in other areas, like close to the brain. But the receptor sends the temperature to the control center, and the control center decides what to do with it. And it sends a signal to the effector, and the effector will will generate a response that will change the value of the variable. So if it's temperature and you were too hot, it will cause your temperature to drop. Most conditions in the body are regulated by negative feedback. Negative means opposite. It means that whatever change the receptor detected, the control center is going to cause the opposite to happen. It's going to cause it to reverse, or the opposite. So let's say that a receptor detects that your body temperature is too high. The control center, which is the hypothalamus in the brain, receives that information and sends the response information for the response to the effector. So one effector would be your sweat glands. Your sweat glands will increase production of sweat, and the sweat will evaporate, and your body will cool off. It will also, one of the other effectors will be the smooth muscle that lines your blood vessels, because it will cause your blood vessels to dilate so that blood can flow faster, and blood can flow more quickly. And that will cause blood to flow to the surface of your skin, and then that heat will radiate off of the surface of your skin. So the control center is usually the brain or spinal cord. The effector is the target that generates the response, and the response is going to be opposite to the stimulus. The response in this case is going to be to lower the body temperature, because it went too high, so now it's going to get lowered. That is negative feedback. And I just gave you one example of negative feedback maintaining body temperature. Here is an example you can look at on your own. It's what I just went through. I just talked about that. And then this is just an example of when body temperature rises, but let's look at when it drops. If the stimulus tells us that body temperature has dropped, the receptors in the brain and the skin will send that information to the hypothalamus in the brain, because that's our body's thermostat. And then the hypothalamus will send a message to our effectors. It's going to cause our muscles to contract, like we're going to shiver. That's going to be muscle contractions will cause us to shiver, and that will help us to get our body temperature to go higher, so we can become warmer. Blood vessels will constrict to hold in the heat. Sweat glands will not produce as much sweat, and then all of these things are going to lead to, those are the responses by the effectors. The effector would be your muscles, your blood vessels, and your skin, your sweat glands in your skin. And the response would be for the temperature to rise because it dropped. So the temperature is going to rise back to its normal healthy value. Blood pressure is another example of a variable that has to be maintained. We want to maintain blood pressure around, we do blood pressure as like 120 over 80, I think is the healthy blood pressure range. So that is an example of negative feedback. Positive feedback is different because what happens with positive feedback is that when a change occurs in the variable, the response doesn't make the variable opposite. It doesn't reverse the stimulus. It actually increases it. So there's not a lot of examples of positive feedback. Most conditions are maintained by negative feedback. But examples would be childbirth. So when you start having contractions, they don't get less. You have small contractions, and those lead to larger, stronger contractions, stronger and stronger until the baby is born. So it's like increase, increase, increase. That's what positive feedback does. Lactation, or the production of milk, is maintained by positive feedback. You have chemicals that are released that cause milk to be produced in the mammary glands, and then more chemicals are released, causes more milk to be produced, and so it's a positive feedback. Blood clotting, when your blood starts to form a clot, the clotting increases until your bleeding has stopped. So example of harmful positive feedback, after you are like you start to hemorrhage or bleed really, where it's life-threatening, the blood pressure will drop, and the heart, when the blood pressure is so low, the heart cannot pump blood, and so the heart's ability to pump blood is less. So that is a harmful effect of positive feedback. But effectors continue the response beyond the set point until the original stimulus is removed. That's what happens in positive feedback, is that the effectors that generate the response, they keep generating that response and increasing the response until the condition is, or till the process is complete. Like if it's childbirth, until the baby is born. If it's lactation, until enough milk has been produced. If it's blood clotting, until your bleeding has stopped. So here it's showing you the labor example of uterine contractions during labor. That's positive feedback, and it just tells you basically contractions increase until the baby is born. So that's positive feedback. Now, these next sections are most important. If you have taken medical terminology, this is going to be like not new to you at all. But if you haven't, this is where we do the medical terminology, because you need to know the terminology when we go into the next chapters, when we're talking about different body systems and their components. So make sure you understand anatomical position, because anytime we refer to a structure in the body, we will assume that the person is in the anatomical position, like this man in this picture, unless you are told different. So anatomical position means that your body is erect. That means you're standing upright. Your face is forward. We call that anterior. Anterior means pointing forward. So your face is facing in the anterior direction, or forward. And then your feet are together, pretty close together, and so your toes are pointing forward as well, the same direction as your face. And then your arms are like at your sides, and your hands, the palms of your hands are facing forward. They're facing anteriorly or forward. Okay, so not the back of your hands, but your palms are facing forward. So this is You definitely need to know that anatomical position. And you can be lying down in anatomical position, but they would have to, whatever situation that's being described, they would have to say lying down in the anatomical position. They'd have to specifically say that. Otherwise, you assume the person is standing up, their feet are close together, toes are pointing forward, faces forward, and palms are facing forward as well. Okay, so when someone is lying on their back and their face is up to the sky, that position is called supine. When someone is lying on their stomach where their face is down, that is prone. And then make sure you know the directional terms. We have superior or cephalic, means up. It means toward the head, but it just means, up. And then inferior means down. Inferior or caudal means away from the head towards, the feet in this case. So I use the term superior for up and inferior for down. Medial is toward the midline of the body. So a structure that's medial would be like the navel, the penis, the nose. Those are structures that are medial. Lateral means that they're more toward the sides of the body, toward the sides rather than toward the midline. So we would say that the arms are lateral, the arms and the hands and the fingers are lateral to the navel. Let's see, proximal versus distal. These terms are referring to anytime they're telling you the location of a structure, referring to either the shoulder joint or the hip joint usually. So like we would say the wrist is distal to the elbow because it's farther from the shoulder than the elbow is. The wrist is distal and the elbow is proximal when you compare the elbow and the wrist to one another. And let's do the leg. So we'll say the thigh and the knee, okay, the thigh and the kneecap. So the thigh is going to be proximal, closer to the hip joint than the kneecap. The kneecap is distal to the thigh. So we say the kneecap is distal to the thigh, and we say the thigh is proximal to the kneecap. So these are just in relation to the shoulder or the hip joint. Superficial means closer to your skin, closer to the surface, and deep means like a superficial cut is a very small cut, maybe like a paper cut. A deep cut, if you're injured and you get a deep cut, that's going to go into like the muscle tissue and maybe further. We also have the terms anterior or ventral, which are toward the front or stomach area. Posterior or dorsal is toward the back area. Okay, so anterior and posterior are the terms I normally use. Here's a table on the directional terms and some examples. So the chin is superior to the navel. That means the chin is up, the navel is down. The chin is higher up toward the head than the navel. And then let's just go to, I think proximal and distal are kind of hard sometimes. Well, these are the examples I gave you, but the elbow is proximal to the wrist. That means the elbow is closer to the shoulder joint. That's our point of reference, the shoulder joint or the hip joint. The elbow is closer to the shoulder joint than the wrist is. The elbow is proximal to the wrist. The wrist is distal to the elbow. That means the wrist is farther from the shoulder joint than the elbow is. The nipple is lateral to the breastbone. That means the breastbone is closer to the midline of the body, and the nipple is toward the sides. The nose is medial to the eye. That means the nose is close to the midline, and the eyes are like to the sides of the nose. They're closer to the sides of the body than to the midline. We would say the eyes are lateral to the nose. We would say the breastbone is medial to the nipple. And then the skin is superficial to muscle. Now, definitely you need to make sure you know these body parts and body regions by heart. This is absolutely, if you don't learn anything in this chapter, this is slide number 44. learn slide 44 and slide 45 before you study and learn anything else. And I'm going to stop here with the recording, and I'll do the last recording starting with slide 44 on the body parts and regions.